Hope everyone is having a good day. Let me quickly share my screen and then let's get started. I hope everyone can hear my voice clearly. If there are any audio issues or anything, please let me know. Mm, okay, perfect. Sounds good. So, as our today's agenda is basically, I want to introduce you to what is AI and what are the different subparts of AI and how it has been evolved over a period of time. So, in this whole 20 hours of sessions that we conduct for the next couple of weeks or few weeks, so we want you to have a generalized idea starting from how AI was developed back in like 1980s or 1970s, and then to the current day generative AI, where we are developing all the agentic tools and all those stuff. So we will take you in a clear path how it has evolved so that you will understand all the basics pretty well. And as well as if you want to build something on your own, your fundamentals and all those things will be like pretty clear. Okay. So I assume a lot of the people in this session, I see like close to 400 people, and you all belong to different industries and as well as different sectors who is working as a software engineer or QA or maybe a student or all those things. So please do, paste to which industry or which sector you belong to so that I can generalize the content I have over here and try to explain it as simpler and as related to your segment. Okay. And now, great. Um, like how many of you use ChatGPT or, Claude or anything like in a regular day? Like I hope everyone uses it, right? Like in general, when you have in the last 3 years, like before 2022, there was no ChatGPT. With the introduction of ChatGPT, and recently we have like Copilot, Gemini, Claude, and Mistral, like whatever it is, we have all of these applications, right? So how many of you use them regularly? I hope everyone uses it, right? Like most of you might use ChatGPT or GitHub or Copilot and all. Yeah. So did you use it to search, summarize, or writing any code or translating something, or maybe if you want to create an image with some popular film and stars or something like you might be seeing like a lot of images being created based on like children, you know videos being generated based on children, like a small 1-year-old kid will be dancing to a song very perfectly, and all these things, right? So, and if you have any questions, is my voice clear?
Yeah, good.
Okay,
Yeah.
sounds good. Yeah, please do check your connection. Yep. So coming back, you all might be using ChatGPT for n number of use cases, right? Even if you have a small question or anything that is so personal to you, or even starting from writing an email, you might be using it, right? If you didn't understand something, ask ChatGPT. If you need some help, ask ChatGPT. In the recent days, probably it might have become a part of us, right? Which is inseparable. So now, today I'm not expecting everyone to become a data scientist with this class, but my goal is to help you understand what actual modern AI is and how tools such as ChatGPT work, and like where people like most of us or businesses use them, and how you can begin building or use AI uh, as necessarily and also responsibly. The word responsibly is more important here. Okay. And let me introduce myself briefly, then I'll quickly jump into it. So, I work as a senior data scientist, mostly building machine learning and generative AI applications for real business problems with big five companies. And I will explain both the concepts and what happens when we take these systems into production, and what are the few elements that we need to focus on. And I see most of your students and freshers. So I will also focus on some of the real-time experience scenarios as well, so that you can like quickly relate. And if you want to explain it to someone during your interviews and so on, it would be like very helpful for you. Okay. Now, this is our agenda, which is like generative AI, LLMs, and real world applications. So, from learning to building and how to grow with AI, we'll discuss all these things. Okay. Now, let's come to the question, why is everyone suddenly talking about AI? Right? So, like, for example, if someone was maybe like in 22 or 21, like when we were still in schooling, or most of you are in schooling or in the plus one, plus two, no one was so intrigued about everything, right? Like, but now, if you want to write an email, you will use an AI. If you want to understand or summarize something, you'll use an AI, right? If you want to create an image, you will use an AI. If you want to create a PPT, you will use an AI. So why is everyone suddenly talking about this AI, AI, AI? Okay, what made this AI explode in the last couple of years, or last 3 years to be specific? Okay, so earlier, like for example, if you want to write code, what would you do? So we have developers who will write everything manually, right? And let's say if you want to generate reports, like all the PPTs and all those things. So what we used to do, like we used to read and summarize them manually, right? Then if we have if you need to write any documents, we would write everything from scratch, right? So similarly, like if you have any customer support agents or all those things, we have like many manual people, many systems, which are like completely manual, right? So now let's say with the introduction of ChatGPT and all, you can write all these codes or get the first draft at least. I won't say ChatGPT gives you 100% effective code every time, but it can generate a very good draft for you. Okay, that is close to, with minor fixes, you can review it and you can deploy it. Right. Also, it can generate all the initial drafts for summaries as well. If you want to generate any reports or so on, it can generate those for you. And if you need any documents based on some topics, yes, it can do that as well. Again, for coming back to the customer support, by using this, it can generate all the suggested answers and give it back to the user and eliminate the manual efforts, right? So now, with the introduction of AI, every industry that we have here has been like evolving, right? So every business adopted it, and the productivity has been boosted at least 10 times, right? Initially, if you had to uh, a, write a code to develop an application, it might have taken like, in order to build an MVP. MVP is nothing but like most viable product. So, or POC, you can say. If you want to build a POC or something, it used to take like 1 month or something when you write code manually. But with the introduction of AI, you can like do it in a couple of days or in a week at the max, right? So if you see, your time frame has been brought down from like 1 month to 1 week. That is 4x. If you do it in like 2 days, that is 10x, right? So that is how it is helping us in productivity revolution. Okay, it is boosting our productivity in such a way that we can complete the task in very few minutes. Okay, so here are the same examples that we were discussing today, or discussing just now. Now, let's talk about AI. So when you say AI, AI doesn't only constitute to the regular, or the recent generative AI. It is like a bigger umbrella. So under AI, there are like rule-based systems, traditional machine learning models, and under the hood, we do have deep learning and then transformers. And the other part is like large language models, RAG plus fine tuning, and AI agents and autonomic systems. So here is a basic evolution of AI. So let's go through each one of them in detail. Like earlier, before the introduction of machine learning, we have these rule-based systems. So what are these rule-based systems? Probably most of you might have seen some of the tax based approaches, right? So, like, let's say if you want to fill a form, like you will just put in all your information in there, and it will automatically give you which slab you will fall under, what will be your total tax and everything, right? So how does it does? Basically, it checks, it does based on the rules it has been defined. Like for example, in USA, it will be something like, okay, if you are in California, you will be falling under 6% bracket. And if you are single or married filing jointly, then they will either couple, like what they do is we will have some limits, base limits of 15,000 exclusions for each of them. So they will give the double of that concession. Like for example, if you are doing married filing jointly, yours 15,000 and yours by 15,000, those will be excluded from your overall income, and the tax will be applied on the remaining of the amount. Okay, so and then if you have a child, that's a different scenario. Again, it will give you some more concession for the dependent or the child. And if you belong to states like California or something, then there will be a state tax applied. If you belong to some Texas, there will be like no state tax. So these are all some rule-based applications you can imply, right? So then you might ask me, oh, can't we do that with ChatGPT and all? Yes, we can do that. But I will explain why it's not a very good idea. Okay. So now, if we just implement a rule-based approach, okay, if the user inserts um, this option or this parameter, yeah, apply this logic, right? In other simplest cases, earlier you might have seen a lot of the customer service flows, the dialogue flows. So let's say you have an issue with the product. So what you'll be saying is, okay, I want to return things. So all it will do is, okay, return. So whenever there is a return keyword, it will send that particular customer to the return department or refund department. Okay, if there is some other word like order history or tracking or membership, so it will just send it to the membership. So it's like a if else kind of approach. Okay, now then we thought, okay, it is pretty much rule based. And what if there are scenarios like we have linear data and non-linear data, right? So what is this linear and non-linear? So ideologically, if you have millions of records, let's say you have millions of records, I will take a simplest example of house price prediction here. So you have two bedroom, you have three bedroom, you have like two bath, three bath, and all these things, like maybe patio, balcony, swimming pool, all these things. Okay. So now, does it, if you give the same parameters every time, like two bed, two bath, and patio, balcony every time, but if you have a different location, you still have to get a different house price prediction, right? The final price should be different based on location. Metro cities will be higher in cost, rural will be lower in cost, and all those things, right? So, what if you have hundreds of millions of records which will have many patterns in it? So, how do you write rule-based approach for all of those? How complex it will be, right? So, when we can't handle thousands of rules, that's when we go into traditional machine learning. So, how does this traditional machine learning models helps us is in simple way. Once we give the data, it will try to understand the patterns from the data. Okay, so based on the patterns that is in the data, it will learn. And whenever we are sending new data, so it will generate a prediction for us, which is appropriately based on what it has learned. Okay. So now, let's say, for example, you have a transaction going on, or if you're working in a financial background. So based on previous customer historical transactions, the model will learn something, right? So for example, you are doing when you are staying in USA, you have a credit card and you might be traveling to, India or some other country. And when you try to make a purchase or transaction, so it will just send you an alert, maybe like fraudulent alert, or it will block your card temporarily. So the reason is there will be some machine learning model which has learned patterns that, okay, this particular user has been buying out of the country, or his zip code is so and so, but he is buying somewhere out of the country. This might card might have been lost or something might have happened, right? So that's when they realize and send an alert stating that, oh, there might be fraudulent transaction, so we are triggering it up. But if you observe, sometimes the model will still understand. Like, for example, if you make a purchase for a flight ticket or those things, right? So the model will have some context. Okay, you made an airlines purchase earlier and you booked some hotels in that region, and then you travel there. So the model will understand all this, your previous transactions of a user, and then it will decide whether to flag it or not. Okay. So this is how the machine learning model learns and predicts. So now machine learning model was learning patterns and giving us an output, and it is very good. So why do we need to go for deep learning? Why do we need to invent or bring in deep learning? For example, if you have data, the numerical or text, then we convert all the text into numerical and we train the model and we'll get the predictions. So what if we have images? What if we have audio? Okay. What if we have a video or, code or some other structured data? Okay. So that's when deep learning came in. So in deep learning, we have like CNN and all those things, which are ideologically used to capture the features based on the images and extract the characters, text, all these things you might have been listening to, some OCR and all those things, optical character recognition and stuff. So how does a AI model extracts all these things? So basically, it is based on the deep learning. Um, we train it based on the data. It learns features and it will identify characters and all these things. So let's not go deeper into it, but I hope you understood why deep learning came in and why we introduced it. So now deep learning was also solving majority of the problems, right? Okay, we have texture, we have like initially numerical data and text data, and we were able to predict. Deep learning was also solving our images, videos, and all the other stuff. Then why do we need to come to transformers or LLMs? Now, until now, whatever you have seen, either it was a classification or prediction, right? That means the output is pretty much like either a continuous variable in the case of regression. When I say continuous value, it can be some, from minus infinity to plus infinity or 0 to 1, but it will be like continuous 0.123, 0.465, something like that. In the case of regression, if I want to predict a house price, it can give me like 1.2 million or 1.23 million or 1.205 million, something like that. It is a continuous variable. In the case of classification, it will be like one class or the other. Like it is a, you know, cat or dog, or target class can be fraudulent or non-fraudulent or things like that. You can have not only binary, you can have multiple classes as well in the target. So similarly, we have like other clustering or those things. Let's not go deeper into it for today, and let's jump on to the transformers or large language models. So if you see, until now, we were just predicting to which class it belongs to or a continuous value. But are we generating anything? Like, for example, if I ask the earlier models, oh, write a poem for me based on Shakespeare's style, can they do it? No, right? The basic machine learning models or deep learning models, all they understood is patterns or characteristics or features, and then just gave me an output based on that, right? It was not able to generate context for me. When I say generate context, if I ask the models or a application to write a essay for me based on any country or any popular personality, so they were not able to do that, right? So with the invent of transformers and large language models, yes, we were able to do that. So how these transformers or large language models perform? So in general, what happens is A transformer will have two components primarily. One is encoder, and the other thing is de encoder and decoder blocks. So in the encoder and decoder blocks, we'll have like attention layers, okay, feed forward neural networks and all those things. I'll go deeper into it later, but for now, just understand the attention, why it is more important. So whenever earlier, all the deep learning models that we train, right, that were either used to generate that were basically collections of text or some code to predict and perform something. In the case of these transformers or LLMs, these are also built on neural networks, okay? But these are trained on large models or, sorry, large or vast amount of data that is available over the internet. So they scrape all the model providers, right? Like OpenAI or Claude or so on. So what they did is they scraped all the data from the internet, from the blogs, websites, everything, all the documentations they could get hold of. They scraped everything, okay? And they passed it and they started training model. How did they train the model? So there are like multiple approaches on how do they train the model. So one such approach is masking. So for example, if there is a statement, okay, so something like I will just say a let me just take this particular statement. The data scientist who joined the healthcare company last year presented her model. So in this particular statement, we will mask few elements like who, we will mask healthcare or something, and we will give this data to the model and ask the model to predict what could be the probable word here in these spaces. Okay, let me just say like this. Okay, so the model will generate something, and then what we already know what should come here. If it comes instead of who, it comes what or something, then it will be calculated as an error. And then we'll do some back propagation, update these weights and all that stuff, and again, finally, come get get to the point like where we predict them exactly or correct one. So now this whole iteration takes millions of computations. Okay. And finally, the model will learn how to exactly predict who in this case and how to exactly predict healthcare in this case. So how does it does? So basically, if we come back to the transformers, we have this attention layer, which is very, very crucial. So that helps us in determining what could be the missing words. So for example, if I say the data scientist who joined the healthcare company last year presented her, and if I don't give anything here, like if it is a dash instead of model, if it is a dash, the model could easily predict what comes next. So how does it does that? So for example, when we send this to the transformers, it will calculate the relationship between each token that we pass. I will come to the token part. A token can be anything. Okay. It doesn't mean a one word is a token or something. It can be a word, part of a word, space, punctuation, or anything. So I will come what exactly is a token and all those things. So for now, just simply understand whenever you are passing tokens to the transformer model, uh, what they do is they will capture the position as well. Like if you pass this data, okay, this is the first one, this is the second one, this is the third one. So they will capture the positional of each token using positional embedding. So I will get into all these things in detail. So for simplicity, just assume whenever you pass something like this statement, the model calculates some attention scores. That means how this particular word is related to all the other words in the sentence and keeps the semantic context of everything. Okay. So in the previous models, all they learned is patterns, but they never learned semantics, right? So when you say semantics, for example, if we have a word that says something like cancel and terminate, these two are same, right? But the previous models was just looking for patterns. Like if there is a word cancel, it gave some score to it. But when it comes to terminate, they gave a different score to it. But ideologically, these two are same. right? So the transformers or the attention scores helps us understand the semantics behind it. So we will go through in detail, like for just now, for simplicity, understand that this is with the introduction of transformers, we were able to solve this problem. And then with the help of these transformers, we built large language models. So large language models can be, decoder only models or encoder only models or a combination of both. Okay. So you see the chat GPT, right? What is chat GPT? GPT means generative pre-trained transformer. Okay. So GPT means generative pre-trained transformer. So it is a decoder only LLM. So basically it will have a stack of decoders and then it will generate the text out of it. So then with the introduction of transformers and large language models, we were able to solve most of the problems. Then why do we need to go or invent on top of this? Like why do we need to introduce RAG or why do we need to introduce fine tuning? So ideologically, all these GPT models, when they, I mean, the OpenAI model provider provides these GPT models to us, there will be a training cutoff date. If you see it online, like for example, all the GPT 4.1, 5.1, or 5.6 models, they have trained until a certain specific date. Maybe, last month or a couple of months before, they'll take all the data that is available over the internet and they will train it. And they will say the cutoff date for this particular model is so and so. What if you ask any real time question to it? Like, for example, if I want to know the stock price of Apple today, would it be able to give the correct answer? No, right? So the large language model won't be able to give the right answer. So, how do we fetch the real time answers or near real time answers or anything specific to our company? For example, these large language models are trained on huge data that is available over the internet. Does that mean that has all the information about me or my company? Does it have all my internal document information or how we do and all that stuff? No, right? Why? Because those are not available on the internet. So those large language models have no context who I am, what I did in my schooling, or who my family is, or where I belong to, or what my company does, what I work regularly, and nothing, right? It doesn't know anything about me or my company or any domain specific information or proprietary information that is related or connected to a company. So, what if I have a large language model but unable to use it in my company or for my personal use? Right? So, that's when we brought in RAG and fine tuning. So, what if we provide my company knowledge base to the model and ask questions on top of it? So, how I feed my company specific data to the large language models such that it can answer most of my proprietary based information or personal information as well. So, that is when we brought in RAG. RAG means retrieval augmented generation. So, where we will have have a knowledge base and we will convert our own knowledge base into like chunks and then we will do embed them into vectors, store all the meanings of our chunks into the vectors and then store it in a vector database. And whenever a user asks a query, we will fetch relevant vectors from the vector database and then provide it to the LLM as a context. So based on that context, the LLM now can answer more specifically. Like if I have any company specific information, like HR details of my company or something, or what investments my company made in the past recent days. So if it has that information, it will fetch that specific information and give it to the LLM, all the retriever component, right? That will go and fetch that relevant information from the vector database and give it to the LLM. So this particular LLM now answers the question that is asked by the user, which is more specifically something like, okay, how many holidays does my company, how many PTOs does my company provide in any year? So It will go to the HR documents, fetch those relevant documents for you, and it will say, okay, your company provides so and so PTOs for so and so years of experience, right? So that we will have some documentation, and when we provide it to the LLM will read through everything and it will say, okay, based on your current experience of 5 years, you will get 20 PTOs in a year or something like that. This is a very uh, basic example. So we will talk about RAG in the upcoming sessions, how RAG happens, how do we evaluate RAG, and also to remember, RAG doesn't mean that whenever you are implementing RAG, you doesn't need a vector database. Okay, there are multiple ways on how we build a RAG. Okay, there are like vectorless uh, RAG approach as well. We'll go through everything in detail. And then comes fine tuning. So, what is fine tuning? Instead of having an additional vector database or additional knowledge base and pulling information from there, what if I retrain the language model, right? So, how do I retrain the language model? So, if you have your company specific proprietary data, you can how you train a machine learning model. So basically, fine tuning is nothing but a supervised approach. So you will have the data and you'll have the labels and you will train the LLM model such that it will have your company proprietary information, and if any domain specific information, it will learn all those things, and it could be of help from once you train it, you could make use of all the knowledge it has learned from the data that you have provided. Now there are like a couple of other things. What is the limitations of fine tuning and all? We'll go through them. And then came the agents. So what are AI agents and what are autonomous systems? So basically, from the discussion just before, you have observed that all these LLM models can generate text and perform, all the extensive computing in the background and provide you something, right? So you are asking something and it is providing you something in return. But if you see the whole scenario is the LLM is acting like a brain. So you will ask something and it will just generate a response for you. But what if I want it to perform task? So when I say performing a task, like for example, if I want the model to book a flight ticket from SFO to Paris, right? So all I'll be giving is, okay, book a flight ticket from San Francisco to Paris if the weather is sunny and the flight prices are less than 1,000 with less than two stops. Okay, so this is my instruction. So what does my large language model does? So basically, it doesn't have any real-time information of the LLM, sorry, flights, right? So what it does, it will have access to some tools. Let's assume it has access to some MCP or something, tool calls or something. So it will be able to, what it can do is it could able to fetch the information by calling those APIs. So once it fetches the information, it will provide you real-time um information like, okay, these are the flights available, these are and so, and the weather is so and so, and all these things. But if you see here, I was talking about weather, I was talking about flight prices, and now also I was talking about non-stop. So here, if I ask all these questions to a large language model without who doesn't have any other external access, it will just hallucinate and give me an incorrect answer, but it could not perform the task. All it says is, okay, um, as this is April, the weather might be sunny, and you can go based on his historical knowledge. Someone might have said on Reddit, stating that, oh, okay, KLM is very cheap. Every time I travel through KLM, so it is very cheap. So the LLM will, whatever it has learnt from those information or training, it will just simply give you that information, but it doesn't provide you real-time information at all. And it doesn't book you your flight. So what if I want my agent to completely book a flight and act as a human? So a human is someone who has a brain as well as hands so that he can accomplish the task. Here also, instead of just having a LLM as a brain, I want it to provide some hands such that it can accomplish the task. So in order to do that, what I will give access to external tools. We'll have MCP and like all the other external tool calling functions and everything. So what it basically does is, once we provide all the necessary tools, it will call. Can everyone hear me properly, or is it like too low? Okay, sounds good. Yep, thanks for confirmation. Yep. So now, we want to accomplish the task, right? Not just providing a written response or something, but it should be able to book the flight ticket for us. So once we provide all the respective tools, so what it can do, initially an AI agent will break down the task, like how a human thinks. If you call a travel person and give your requirements, how does he think? Okay, my customer wants to book a flight ticket from San Francisco to Paris, and he wants less than two stops. That means like one or none, non-stop or one stop. And then his budget is $1,000. And the other thing is he wants to book a flight ticket on a sunny day, not on any day, but specifically on a sunny day. So what that travel person does is, okay, initially he will go to a website and looks for what is the weather in Paris for the next 1 week or 2 weeks. Then he will see when it is a sunny day. So this is task one, right? So here, like, get weather information is the first task. Then after getting weather information, he will get the dates from there, right? On which day he will get few dates, maybe one, two, three, or few dates. The reason why he need few dates is on few days it might be the flight ticket might be costly, and other days, I mean, if it's a weekend, the tickets might be costly. If it is a regular day, the tickets might be cheaper weekday, right? So it will get the dates on based on the weather. Okay, on which days the weather is sunny, and then what he does is he will get the flight uh, prices. Maybe he will look in Google, get all the flight prices. Okay, so he can do it in directly. I mean, instead of getting day, he should identify what are the sunny days first, and then in the Google flight prices API call, he will insert all these dates and check what are the flights available under 1,000. And under 1,000, then the next thing is less than two stops. So a manual person will check all these things step by step, right? So here, if you see, in order to perform all this, the manual person does all the steps autonomously, right? So there is like no rule-based approach or something. He understands, okay, initially I need to fetch weather, then I need to get dates, and then I need to fetch the flight prices and see on what are the dates that is sunny, what are the flight prices on those dates, and are these under $1,000, and are these under two stops, right? So now, if you want to mimic the same behavior using AI agents or any application, so if an application or can perform these tasks individually or autonomously, when I say autonomously, we should not indicate, this is step one, this is step two, or this is step three. It should autonomously decide what to do. What is your first step? What is your second step? What is your third step? And if it has to go back and fetch weather information on any specific timings or something, like it has to loop through it, and it has to autonomically decide which step it should take next without any human intervention. So if it can decide all these things autonomously, then we call those as AI agents. Okay. So I hope everyone understood what is the plain difference between like regular AI application or AI agentic application. Okay. So now let's discuss some limitations of AI. So if you see, earlier we have some problems based on like in the initial rule-based approach, we had like simply hard-coded the rules, which can become complex over a period of time, right? If we have very complex data, millions of records, writing rules for those many records would be like pretty difficult, right? So that was one of the limitation, and there was like no reasoning. So when I say no reasoning, few models they couldn't understand like the difference between like what is cancel, what is termination, and all those things. And also, they couldn't reason properly, right? Like when to call which, I mean, like for example, when to take first step, when to take second step, and so on. Earlier, what we gave is we just asked them to either follow a sequential approach or perform it in a uh, regular direction, right? So, no memory. So, the thing, what is memory means is like whatever we ask, right? Like to a ChatGPT, it will remember your whole conversation, your whole history. So there is two types of memory. One thing is short-term memory and one thing is long-term memory. So whatever you are giving in a session, like for example, you are opening ChatGPT and opening a new chat window and asking questions to the model, what it does is it will keep the whole session, like that particular chat window will have a session memory. Okay, so whatever you ask in that session, it will remember everything and it will be able to respond accordingly. Okay, but recently, if you might have seen that even if you open a new chat window, it will still remember who you are and some facts about you. Like for example, I'm a data scientist, and if I ask any question in a new window stating that, okay, I'm facing some issues in logging I'm unable to view the logs in the UI. So I didn't give it like whether it was a cloud platform, it was an on-prem, or whether it was a GCP, Azure, or AWS. But it remembers the context that I have been working with GCP for a very long period of time, or have been working with Azure for a very long period of time. And it will be able to deduce that, okay, in GCP, there is this log explorer and there is this log name. Can you try filtering your logs based on that log name? And so on. So how does it know? Even in a new chat window, there is no previous session memory and anything at all, but it still knows who I am and what I do. And it remembers few of the applications that I worked with. So how does it remember? So what happens is in every session after, like, for example, you ask something in the session and you will go to new session or something. So what does this ChatGPT does is it will concise or it will extract few of the important information from that session, like not all the input and output, um, input and output that you have provided and received, not everything, but it will just take few of the critical information from your session that, oh, okay, Sripal, earlier Sripal was working on GCP. He usually export logs to this log explorer or something. It will remember few highlighted elements. Okay, Sripal mostly works with GCP, and he recently built some logging for his application, and it usually has this particular logger name or something, and it will just briefly context everything and take that and store it in its long-term memory. Okay. So earlier AI, traditional ML or those things, they have no idea. Everything will be like a stateless and new request or new prediction, right? And contextual understanding. So what is meant by contextual understanding? So we just discussed earlier. So when we say cancel my membership or terminate my membership or, um, you know, I no longer want to continue with you. So these all words say the same thing, right? But only the LLMs can understand uh, the contextual meaning of it or the semantics of it, right? So all the previous AI models were unable to understand these semantics or context, and scalability was very limited. Okay, so now the reason why the scalability was limited is earlier to LLMs we have some of the VAs and GANs, generative adversarial networks and all, and LSTMs also, which were slightly able to understand the context. I mean, slightly, not everything. And also, they were able to generate context, but in a very limited format. Like they are not scalable, like how ChatGPT is giving us a response of thousands of words in a seconds, right? So those are not able to generate those many things. So they have all the limitations for scalability and all. So that is why with the invent of transformers and LLMs, we they can be like scaled up to, as you are seeing, what is the capability of those. So I doesn't need to specifically say how capable they are, and it was able to solve this limitation, which earlier AI models was unable to solve that. So now you know the reason why AI exploded with the introduction of LLMs, right? So all these things, like having memory, having contextual understanding, having scalability, it helped LLMs to traverse into everyone's path. Like if you name any industry, yes, that industry will be using AI, like medical, pharmacy, technology, finance, banking, manufacturing industries, like government also even, right? So every industry has using this AI in these days. So these are one of the important limitations that the model was able, these LLMs were able to solve, and that resulted in the current day AI explosion. Okay, so now I hope everyone got an understanding of how we evolved from pretty basic rule-based systems to the current day AI agents and autonomous system, right? So now let's talk something about. So for our further classes, as we want to learn more about the generative AI and AI agentic stuff, I'm not gonna talk anything about the traditional machine learning or deep learning. I will focus right on transformer, which is like a core part of all these LLMs, and then into building on top of LLMs and all those things. Okay, so as we have like limited time, let's make most use of it. So the breakthrough, as we spoke earlier, the breakthrough came with attention mechanism. So what is this attention mechanism in general? So whenever you provide something, in the earlier case where we took a statement, right? Where was that? Yep, here we took a statement. So basically, when you insert or when you pass this particular statement to transformers, what it does is it will help the LLM determine which words or tokens. Like for now, simplicity, let's use it interchangeably. But I will explain you in detail what tokens and everything else going further. So which words or tokens are most important when you try to interpret or generate the next token. So how these transformers work is when you insert this particular sentence and you want to get the later tokens or next words, remember one thing, all the LLMs are next token prediction. So what does they do is they doesn't generate sentences. So they will generate token after token. Like for example, if I have an LLM here, this is one of the important part that you should remember. Okay. And I asked, write an email to my HR manager. Okay. For a promotion or requesting a promotion, something. Okay. So if I give this, what happens initially? All these particular tokens will be passed to the transformer. Okay, I'll just say transformer here for now. Okay. So when you pass all these tokens to the transformer, it will calculate all the attention scores or something, and then it has to give an output. So how does it give an output? Initially, it will only generate something like dear. Okay. So once you give this as an input, the output, the first output will be dear. And what happens is you will send all these instructions along with dear to back to the model. Okay. And then it will generate other word, which is dear manager, other token. So then you will pass all these things again to the transformer. Okay. Then it will give you next word stating that it will be like I. Then again, when you pass all these words, it will give you hope. Then it will say you. Then it will say are. Then it will say doing well. So again, every time you pass all these things back to the encoder or decoder inside the transformer, and it will just generate the next token. Okay. So this is how a transfer like decoder in a transformer works. Okay, and this is how an LLM generates an output. So it will be like a streaming. So if you ask, you can ask me, oh, how it could generate all of those things in a milliseconds. Yes, it can. So that is the reason, we need GPUs for that, where the compute can happen in like milliseconds. We do all those KV cache inside the, I mean, KV compute, all those millions of compute or billions of compute in the GPUs in pretty millisecond time. Okay, so I hope everyone understood like how transformer or LLM generates an output one token after the other. Okay, so now coming back, let's learn about attention. So basically, the attention component in this particular transformer, it allows the model to look at all the relevant words in the current context. When I say current context, the whole input is my current context. Okay. And decide how much importance it has to give to each token. Okay. So, for example, I have email. How important is email to HR? How important is email to manager? And how important email to promotion? So, it will try to capture all the scores of this relationship. Okay. For example, I'll also give another simple one. Let's say the dog did not cross the road because it was tired. Okay. Now, if you see, the dog did not cross the road because it was tired. Here, if you have this it, right? So, does this it means, is it referring to dog or is it referring to road, or I'll say street? Okay. So, what it is referring to, whether it is the it here in this sentence is referring to dog or it is referring to street. Usually, it is referring to the dog, right? But how does the model learns that? So that is through attention. So what happens in the back end is, so the dog will have high attention score related to it. Okay. When you say for it, what is the attention score with corresponding all the words in the context, the dog will have highest score. So with the road, it will have, or with the street, it will have minimal score. And all the cross, did not, and all these things, it will have very minimal score. Okay. So I hope everyone understood what attention captures. Okay. It captures how well each of the important tokens are interpreting and how those are like relevant in the current context. Okay. So uh, now I hope everyone understood the basics of how a LLM and transformer works. So in depth, transformer has a very good architecture which requires whole 2 hours or 1 to 2 hours of session where we need to go through in detail. But for simplicity, just assume that you'll have encoder decoder layers in transformer. Okay. And you can build your LLM based on decoder only models also. It doesn't mean that you have to use both the components. And in these two components, you'll have attention layer. Okay, you'll have attention layer in both. and there will be like feed forward uh, network. That is another layer. We will do like a lot of computations. Like what we'll be doing is initially, I will explain those things if time permits tomorrow. So initially, we will pass whenever we have a sentence, we will chunk this sentence into tokens. So we will use a tokenizer and we will split our sentence into respective tokens. Okay. And then we will attach positional embeddings to it. So once we convert it into tokens, we will embed them into vector. Okay. That is, as we know, the machine can only understand um numbers, right? They doesn't understand text or anything. So you need to convert this into numbers. So how you represent your tokens in a numerical format such that it will store the semantics as well. So that is how you embed in all these tokens, and you will add positional embedding to it. So what is positional embedding? So for example, you have this particular statement, right? If you flip any word, like let's say you have this word, if you take not here and if I put it here, the meaning of the sentence changes, right? Like the dog did cross the street because it was not tied, right? Just the placement of one single token change the meaning of the whole sentence, right? So we should not uh, change or we should capture the position of these words such that we don't change the meaning of the sentence. I hope everyone agrees with my statement. Then what we'll be doing is we'll add positional embedding to it. Uh, like okay, I will just write it down. In first, we'll convert it into tokens, then we will convert it into vectors, and then we will add positional embedding to it to these vectors. Okay. So once we add positional embedding, then we will pass it for attention layer where we'll calculate all the scores. So before in attention layer, it will generate like QKV matrices, query key value matrices. So what they does, there will be some performation, calculations inside it, you know, K matrix multiplications. So I don't want to, cover all those complex things for now. I don't want to confuse people, but for simplicity, understand. Then we will pass all these vectors into the attention layer where it will undergo some computation and calculate all these attention scores. Okay. So once it calculates all these attention scores, what we have to do is it will send it forward. So these attention scores can be anything, right? So we had to minimize or bring them under like 0 to 1 or whenever you are predicting a next token, right? So in simple terms, we will apply a lot of logics on top of it, transposing it, and so applying a softmax layer on top of it. And finally, we will predict the probability of each word or probability of next token that needs to be generated, right? For example, here, if we have like till it was, so what is the next probability, whether it was tied or whether it was um, what do you say, another word for tired or something is okay, energetic, or whether like I'll say lazy, whether it was a tired or lazy or not in I'll simply say bad mood. So what is the probability of tired, or what is the probability of lazy, or what is the probability of bad mood right after it was? So this is how this tide will have like maximum probability 0.8 or 0.6 something. This might have 0.3, 0.2 something. So that is why based on the highest probability, we'll get this word as an output. I hope everyone understood this part. We'll go, if time permits, we'll go through the transformer layer also. I will explain in detail like what each component does, but keeping the audience in mind uh, and uh, and their capability to understand complex things in the very first class. So I will just limit it I will limit the today's discussion. So now we went through attention mechanism, what it does and how it captures the relationships and everything, right? So now we know how it captures the context awareness, and parallel processing. So what is parallel processing? So earlier, right before transformers, we have LSTM and all like various other models as well. LSTM is long short-term memory. So the name itself says short-term memory, right? That means it cannot store, it cannot remember long beyond certain things, or it might tend to forget. If you give longer context, like let's say if you give 1,000 words, it can remember. 2,000 words, it can remember. But if you give 5,000 words, it might forget what we gave in our initial paragraphs or initial 1,000 words. Okay, it has some input gate, forget gate, and all those things. The mechanism is slightly different, but those were also able to generate text earlier. So how do they, process text earlier? So how did they process text earlier? For example, if I have the same statement here, okay, so it doesn't take all my sentence at a time. Initially, it will divide into then I will have something called as dog, okay, then I'll have something called as did, then not. So what happens here is it will pass or process the statement sequentially. Initially, it will send the, process it, remembers what this the means, and then it will send dog. Then remembers it. Oh, okay, now the sentence talks something about dog. It has some score, and then it will pass did, and then it will do not, and then will compute based on the previous words also. The previous words has some scores and all those things, right? It will process it and it will append it. Similarly, we are doing this in a sequential process, right? Like one after the other. So, how much time would it take if I have to process millions, like 500K words or 400K words? It will take a lot of time, right? And whether it is scalable? No, right? If you send those many words, what happens? It will tend to forget. But here, in the case of transformers, we do parallel processing. So you will send all these tokens at a time. You will append positional encoding to it, and then you will send it at a time. Earlier, we didn't have the need for positional encoding. Why? Because you are sending them first word, second word, third word. So the model knows based on the order it is receiving those words. But in case of transformers, you're passing all these tokens at once, parallelly. Okay. So that means we should be able to differentiate which word is first and which word is second. So that is the reason we add positional encoding to it. I hope everyone is clear till here. So that is meant by parallel processing. So you can process all your text at once parallelly. And as you know, this particular based on because of the attention layer, we have better language understanding as well. So grammar and all that stuff, and long context reasoning. So as I was telling earlier, LSTMs were able to handle only smaller context, 2,000 or 20,000. But when it comes to 200,000, 400,000 that we are seeing in the recent or transformers, recent LLMs, right? So where we have like longer context, our context is up to 1 million tokens now, right? So that is one of the crucial breakthrough that we brought to transformers. And to be honest, when ChatGPT 2 was introduced, probably you might know that the context window was something like 2048 tokens only. And the later subsequent GPT-3, when they came, they have like close to 8K tokens, right? But I mean, last year or a few years ago, if you have seen few of the models, those will have a context window of 8K tokens. So I hope everyone knows what is a context window. Context window means when you open a ChatGPT, in the message bar, how much text you can pass. Like sometimes it will say, your token limit exceeded or context window exceeded, right? It will not allow you to pass more than that. But now for the GPT 5.1 and all those things, we have like 1 million token size. So what changed here? The transformer architecture is same. Nothing changed with the transformer, right? So how are we able to increase the token size from 2,000 to 1 million? Okay. Did anyone had that doubt earlier? Okay. So one of the crucial component is positional encoding. So initially, when we have this context 2048 tokens, right? Or 8000 tokens, we were using standard positional encoding. Okay. So we want to capture the position of words from first word to the millionth word. We can't store, like, if we append something like, let's assume my base vector is something like, I'm just giving you random numbers. Okay. Let's assume I have a base vector 0 0.1, comma 0 0.1, comma 0 0.2, comma 0 0.3, and so on. This is my token vector. And I have to append a positional embedding to it. So what does my positional embedding looks like? For example, if I say 1, assume like I have another vector where it says 1 or something. If I add my positional embedding to my actual token, for millionth word, I should say 1 million, right? So if I append 1 million to this particular vector and ask the model to calculate attention scores, the millionth word will have highest attention score. And every time the next token prediction will be the millionth word only, right? So that is not the right way. How do you do it? So that's when they introduce the sinusoidal or cosine waves. So if you see, the sinusoidal waves will look something like, okay, something like this, right? So what the store is, the range will be from -1 to 1 or 0 to 1, right? So for sine wave or cos wave. So what they do is they will take positions. There will be some formula 1 by 2000 something. So it depends on whatever token size that we are giving in. Okay. So then came rope, rotary positional encoding. So this is a whole different, like, this is a whole new area. So what happens is, instead of going with the regular standard way of positional encoding, this bot into picture where we can give millions of values that ranges between a certain window. Okay. So don't worry about these things being complex. If time permits, I will explain you in detail, but all you need to know is, okay, how we increase, how the context window has been increased from 2000 or 8000 to 1 million. So that is with the help of rope. So what does this rope does is, it gave degree also. When I say degree, it not only gave the like, let's say, for example, let me just do it in a very simple way. These things can be slightly complex, but those are not complex, believe me. You just need to repeat this. That's it. So let's assume I have a three-dimensional or n-dimensional space. You all know what is a two-dimensional and what is a three-dimensional. Assume I have an n-dimensional space. Now, if you see, I have this vector, okay? And I have another vector, okay? I hope you can find the difference with it, right? So I have like two vectors. Now what I'll be saying is, I will just closely put this together like this. Okay. So in this direction, you might be thinking that, oh, these two are at one single location or one single point and gives me the same value, right? But no. In general, look it from another direction. In the other direction, what it might look as, let me just show it to you. This is from one direction, right? So in the other direction, like this particular vector might be sitting right on top of it. Like when I say right on top of it, for example, there are like three persons. Okay, so let's say one. Just try to use your imagination, okay? So there are like three people, and this person is viewing in this direction. Okay, so what he sees, he can only see the first, this particular second person here, right? He won't be able to see the first person, right? But what if this person changes his direction and comes here? So now he can identify these two are different. I mean, he doesn't only see the second person, but he can also see the first person and he can see how they are separated, right? So that is how the rotary positional encoding works. So with the introduction of this degree angle into it, so initially it was only first position, second position, and all those things. But now we brought in angle as well. So when we brought in angle, we can increase our context in such a way that it can explode up to 1 million as well. I hope everyone understood it. I know it's a bad example, but I think you can all understand it. I just wanted to simplify it for you. There is like complex thing involved in there. So it will basically store relative position and ignore the actual positional value during the matrix multiplications. So it is a lot of maths involved. So let's not go to that and I don't want to confuse you people. So that's why let's just uh, get it done here. So I hope everyone understood how this thing happens and why it got exploded and all. So now let's just reiterate what is an LLM. So an LLM is new, like machine learning, I can say an AI model or a neural network model, which is trained on massive data. Massive means like humongous data that is available over the internet. And it learned and identified all the patterns, how each word is related to one another and everything. So it has learned all those patterns and everything. And it has also run reasoning, how the semantics, how to, give the semantic outputs, how to understand the semantics and everything, and how to generate the next token prediction and all that stuff. So now how these actually works. So we just went through how it just predict tokens. LLMs are nothing but it just predicts the next token, right? So what is tokenization? We will discuss, and probabilities. We briefly went through it, and we already went through context prediction, and we'll also go through embeddings. So first, let's go through the embeddings. Okay. So what are embeddings? Embeddings are nothing but meaning stored as numbers. If you have a text, okay, and as the model doesn't understand the text and it only understands numbers, if you give 1, 2, 3, 4, the model doesn't understand anything, right? But what if you tell the model that, okay, when something like king comes in, he will have this vector. And when something like a man comes in, he will have this vector. And if you see, those two might be identical, like 0.3, 0.4, 0.5, 0.345. And these first two things might be, the first two values might be stating something about the royalty or authoritative power or something, authoritative power or something. Okay. But in general, if you see king, these two vectors are identical. Why? Because Raja means king, right? We all know that. Like in some languages, we call it as Raja. Some people will say king and things like that. So now, if you see here, even though we have different words, based on the semantics, we are storing the word Raja, or if you have a sentence also, we can store that whole meaning as numbers as shown in here, right? So that means you can simply store all the characteristics of particular thing, of particular text or token into this vector format where we can store all the meanings and everything, right? So the meaning is intact, the semanticity is intact. I hope everyone understood this point here. Whenever you say, someone asks you, okay, what are embeddings? Embeddings are nothing but numbers that store meanings, okay? Or you can simply say, like, those will capture the meanings of a sentence or whatever tokens you pass it to it. So now, how does it helps? So it helps in semantic search, providing any recommendations, and also, when you want to create vector databases for RAG and all those things, these embeddings are very important. Now, The other thing comes in, which is nothing but tokenization. So what is tokenization? So you have a sentence or words. When you are training an LLM, what we basically do is we will try to identify what are the unique words. Okay. So as we know, when training an LLM, we scraped all the data from the internet and everything. So we got all those data. I have assume I have passed everything and I have a huge text. And in that huge text, I will take all the words. Assume queen, king, raja, prince, everything. I took everything into account. So then came into picture something called as, let's say I'll just take this same example in order to understand. Or else let me do this another one. I okay, so, we just done with mango season, so I will just say mangoes. I love mangoes. Okay, or anything like let's take this example for now. So here in the while training, the model might have seen these words already, and what it will think is okay, this I is one word, so I will give it a token or identity, which is nothing but numerical identity. It is one. Then I will say love. It is another word. Okay, then I will give another identity, which is two. And it might have n number of words like that, right? So what it will do at the end, there is this mangoes. So mangoes might get 1 million or something word, 1 million 3 or 1 million 4. For simplicity, I'll just say 1000 not 4. Similarly, we have like millions of words, right? So if we have to provide token ID for all of this, what happens? We will get millions of token IDs. And when you pass words like here, if you see mangoes, I have man, go, yes. So in my huge data that I pulled from, I'll also have another word called man, which will have some 2005. And this one will have 4003. I'm just randomly putting the numbers, okay? This one will have 1.325 million, okay? And if you see here, I might have M, I might have A, I might have N also, right? Why? Because we might see individual characters also in the training. So that is an alphabet. So we will have tokens for token ID for these as well. Okay. So I will say 2004. I'm just randomly giving the numbers here just to make you understand. Okay. So if I just keep on going, I will get millions of words, right? Millions of combinations of these words. There might be millions of combinations of words that has been over the internet. So whenever I am passing it in my context, how do I identify that? Right? So if I take individually every time, like mangoes is one thing, and I might be having something like a mango, right? This is just a plural form. But what I'll do, I will just give another token for this, right? If I give a unique token to each word that I see, what I'll be doing is I'll give another token for this, probably 1003, right? So few words like apply, application, applications, applies, applied. You see, each one will have a individual token for all of this. So wouldn't that explode our like memory, like not only memory on how we deal with the things? So what happens is the context window is crucial for our LLM, right? We have a limited context window. That means like let's say we have 8,000 tokens only. Okay, we have only 8K tokens. Okay, so that means we can only pass. We might hardly, the model might be thinking that I can only pass MANGO, something like that. When we say mango, it doesn't understand the necessity of how exactly to pass, and we might explode the number of tokens, right? So how to minimize this? How do we store this in an effective format so that we doesn't give repeated words to all of this? Can we compress them? So that is when That is how a tokenizer works. How this tokenizer works is when we have a word mangoes during its training, it will see how much frequently the words it has seen. Like if it has seen M more number of times, it will give M a token. M will be a separate token. And if it sees A and G O more number of times, it will give A and G O another token and ES another token. Or it might give something like MAN. I have seen MAN a lot of times, so I will give MAN one token. Then GO another token and ES another token. Okay. So when it gives it, we will identify this whole thing. Like whenever you see mangoes, you will represent that mangoes with the combination of this token. I'll show it to you how exactly it works. Um, okay. Okay, now you see I is one token and space plus love is another token and space plus mango is one token and ES is another token, right? What if I use these are like multiple tokenizers. Okay. If I pick another one, yeah, most of them is using the same thing, but yeah, if you see here, this whole I love mangoes is represented like this. If I just take mangoes, okay, so this is how it represented. You see how just now, earlier it showed the whole mango as one. Now it is showing individually, like M is one token, ANG is one token, and OES is another token. Okay, how does this does? So the whole logic behind this particular tokenizer, okay, will take all these characters and represent this whole word in this way. Whenever I say mangoes, it will be represented with the combination of tokens. M, like if you see here, right? M token ID is 76. ANGO token ID is something like 7518. And ES token ID is something like 268. And whatever is there after space or something, it gave another token ID for that. Or it is end of sentence or end of something. Okay, I hope everyone understood this. So now we are representing mangoes as a combination of multiple tokens, right? So this is how we represent, and it reduces the number of tokens. So for example, I can show this to you clearly if I have a longer statement. I love mangoes. See, earlier for GPT-3, we had 11 tokens. If you see the GPT-5, it has only 10 tokens. So with the introduction of how we compress these tokens effectively, our token count will be reduced. So once we reduce the token count, we can process more text, right? So usually every model provider, right? So OpenAI uses these three token. Earlier it used to use GPT-3 for GPT-3 models. Then for 3.5 and 4, they use these GPT-4 tokenizers. They will retrain these tokenizers based on the data they have and all that stuff. So what they usually give is initially they give a like a number to all the unique words that they see, and they will try to compress those words together and generate a combination of tokens. So how we do that? This is like another long story, but in short, you can remember this. I hope everyone understood this. So here you can see this thing here. So tokens are nothing but those are like a sequence of characters found in a set of text. Okay, so the model learns to understand the statistical relationships between these tokens and excel at producing the next token in a sequence of tokens, right? So what they basically do is when we process these tokens, whenever we are trying to predict the next token, it will just give the token ID. Like initially, it will give a probability to a token ID, and that token ID, if it has A and GO or if it has M or whatever it has, it will give that as an output. Okay, I hope everyone understood how the background of LLM works and tokenizer works. And these are not same for all the models. Anthropic will have their own tokenizer. Meta will have their own tokenizer for Llama. Each model will have their own tokenizer. Okay, so that the model will just give the final token ID and then they will trace it back based on the attention scores or something. Okay, I hope everyone understood this part. Coming back, if you give any new, like we will discuss more to it if needed in the next class. So I think we are like about time. So I don't want to overwhelm things. I will stop here. And if you have any questions or anything, I will, let's open the DAS for those questions. Please raise your hands so that, we can unmute you and you can ask the questions accordingly.
These people. Yeah. Please raise your hands so that we can help you on the queries and answers as well. So before that, we'll be starting a new batch, like a 100 day plan new batch. So please try to see if we can, register for that. So that is kind of a full track course where we have like 5+ mentors who come and teach their parts. Please see if we can, also, we will try to give you school account where we have 30+ recordings, especially the important boot camps. You can listen those from our mentors. If you like it, so you can book for a full track course where we help on training and also placement and will help placement part. So we will help on projects teaching and we'll help on internships. So please try to see if we can register new batch form. So from our admin team, can someone post the new batch form? So fill the form. It's not mandatory to join. You can have a one-to-one discussion with your queries, get it clarified, and if you like it, you can join with us. So that program will once you pay, you are allowed to associate with us for next 6 months. You can join 1-2 batches freely, and you will get 150+ hours of recordings of previous batch, 30 GitHub projects we designed in GitHub. You will get access, and you will get free access to current batch recordings and the upcoming batch classes also free of cost if you miss any classes from the current batch. So that's one announcement I am trying to do. Please try to register for the school account as well. So this is the school account we give access for free. You can listen these recordings. Normally we have separate school account for USA, but for India, this is where we organize.ai. So we will send you this link so you can sign up. So by default, you don't need any access. You will get this classroom access. So every year we conduct boot camps from 2024 to 2026. You will get access to these recordings. These recordings is to make you sure that how we teach, how we help the career guidance side and subjects wise. There are multiple mentors who come and help you on the certification side, use cases side. So please try to register. So yeah, we are open for query session now. Please raise your hand. We can unmute one by one. Let me see who
Yeah,
can.
Kameshwar,
Yeah. Yeah, please,
I'm
Kameswara,
sorry, like,
please unmute
yeah,
yourself. Yeah,
sorry
please
if
unmute
I spell
yourself.
your name wrong. Okay, I expanded my window now.
Okay, I
Yes,
think he is not able to unmute. Retigar, can you unmute yourself? I'm trying to unmute you. Pyras Reddy. Yeah, please.
yes.
Yeah.
Firas, can you please unmute yourself? I mean, if you have any questions, you're permitted to talk.
Yeah.
Okay, Srinath,
Yes, sir.
hey,
Are you
Srinath.
able to hear me?
Yes, I can
Yeah,
hear you.
yeah, yeah, yeah. Sir, your session is quite engaging and informative. I appreciate it from the bottom of my heart. I mean, it's really amazing, and I
Thank
want
you.
to do any course if applicable in future. So, like sir was saying that we will form a batch of 100 and we'll start a batch. So, I'm quite interested in it.
Oh, great. Thank you. Like our team, you can reach out to the team as Ramgar mentioned. You can fill those forms or show your interest over there, and our team will get in touch with you. Okay.
Sure, sure, sure.
Yep. Thank
Thank
you.
you, sir.
Thank you for the words. Thank you. Sampath Kumar. Uh, yes, Sampath. You can unmute yourself if you wish to talk. Okay, Vishal Kumar. Vishal Kumar, do you have any questions? I see your hand raised. You can unmute yourself and okay. Rajiv Saha, do you have any questions?
Am I audible?
Yes.
Thank you. Yeah, it was a great session, first of all. The question that I have, I'm not sure if you could do maybe uh, take that in the next session, is
Hmm.
how do we increase the attention of a particular thing? So let's say I'm giving millions of tokens or
Hmm.
words to the LLM, and I want to specify that, okay, this is where you have to give more attention to. So how can I do that? Is it possible, or it solely depends on the LLM?
Oh, it wholly depends on the LLM. So the process of how we calculate attention is basically a mathematical formula.
Mm-hmm.
Okay. So unless and until we change that mathematical matrix multiplication formula, so it doesn't change. So you can
So
include some things, but it has to happen during training of an LLM, not during other prediction that we are doing right now.
okay, so as a user, when I'm giving the context, I
Hmm.
cannot I cannot tell the LLM that give more weightage to this particular context and
Yeah,
give less.
you can give that in as a prompt. Like for
Mm-hmm.
example, if you want you some of the like how this happens is understand you cannot specifically say to the LLM that if I give something like a cat or dog for animals, you give high priority or something every time. But in your prompt, if you include that, like in your system prompt or in your user prompt, right? So if you
Mm-hmm.
have a question, something like review this document and identify fields that are medical terms and give the technical terms in the medical like in the medical terminology or something. Okay. So
Mm-hmm.
you are saying the model that you should provide the answer in the medical terminology. So you are giving more weightage to it. So the model, while calculating these attention scores in order to predict the next token, right? So based on your
Mm-hmm.
instruction, it will think, oh, the user is asking specifically for this, so this is more important. It will think this is more important and it will give you accordingly. So you cannot modify or turn up the attention that is associated, but you can give instructions to the model by normal prompting for a pre-trained LLM. Okay. So
Mm-hmm.
already the LLM is pre-trained. You can't change the attention layers over there, but you can make an impact on your output, like how you should get a different response. So when you are
Through
getting
the
different
prompt.
response means it means the attention calculator is different, right?
Mm-hmm.
So that can be achieved through the prompt.
I see. So the problem is that what is
Hmm.
happening, I believe. So I'm trying to design. I'm not an AI programmer or anything. I'm a
Okay.
normal.
Hmm.
But what I'm trying to design is basically a kind of, let's say, a log analyzer
Hmm.
that I have lots of log files, and I wanted to let the LLM decide, okay, what is the problem? But the problem is that here, it's a huge prompt, right? I'm feeding in a lot of files. So, and out of that, it has to decide, okay, which one might have caused it. So, and I want to give some kind of, you can say some formula so that it can figure out, okay, it has to give more attention to these things. Is there any way to do that? That's what I'm trying to understand.
Oh, okay. Yes. So I do appreciate. So how this thing happens is the LLM is trained on general information or generic information, right?
Mm-hmm.
So there are ways, like I work at like uh, Microsoft earlier. So what happens over there is when we have all this information, right, related to like logs or anything, we train few models. We fine tune few models based on the log information that we have over a period of time. Like we will take all the historical logs. For example, the simplest thing that I can say is we do most of the work on Azure. We are Azure, Microsoft is Azure native, right? So we do most of the work on Azure. So in Azure, if you see, there will be like a lot of errors for each service, right? So we thought of building a chatbot, like an application. What it basically does is when you have these pipelines, if something breaks in the log, it will try
Mm-hmm.
to see what has broken,
Mm-hmm.
identify the task, and it will modify what was the input that we have provided to the pipeline. It will change those parameters or change some instructions and again get the job done. For example, the simplest thing is you might be using Copilot, right?
Mm-hmm. Yes.
GitHub Copilot or anything on your IDE, VS Code or anything.
Correct.
So what
Correct.
happens is you will write some code and when you run that in a notebook, it will, or in the terminal, it will generate some log for you. I mean, something over there stating that, oh, this has failed or no, some error, assume.
Mm-hmm. Mm-hmm.
So what does that Copilot does is when you give this to the Copilot, all these codecs or these things are specifically trained on this coding errors and syntaxes and all this information. So they are like fine tuned on top of this.
Right.
So it will fetch like either it has that information. If it doesn't have that information, what it will do is it will fetch that from the documents. Like, if there are any you are trying to connect to Google services from your VS Code and you are getting an error. So that particular model might have an idea about it or might not. So what it will do, it will try to go and fetch the Google documentation pages, read them, and once it reads them, it will try to say, oh, this error 501 is coupled with so and so issues. So this might be the issue. So I need to change some Docker file or some libraries or some packages. So then it will say, you need to update your Google package or G-Cloud package or something else, and it will give you particular version or update some code, how you are loading them, and all that stuff, right?
Mm-hmm.
So if you see here, that has a context. If the LLM has a context about what you are asking, then yes, it does give you the right way and it also reasons in the proper direction. So in your case, if you want the agent or if you want the AI application to look at all the logs that you have and figure out what's wrong with it, identify whether that has a context or not. Just don't use generic models. Even if you use generic models, use the latest models. So
Mm-hmm.
initially try with few prompting that, okay, does the generic model or that the model providers provide has enough context on your logs or not? Was the model able to understand all the logs or not? Then
Mm-hmm.
if you have any historical information, like let's say you already saw that failure earlier and you have a particular solution for that you have approached last
Mm-hmm.
time. So
Mm-hmm.
if you have those documentation, provide that using RAG approach. Okay. So I wouldn't
Mm-hmm.
say directly go to fine tuning just now, but initially try with RAG approach. So that will make you understand like you have your company specific log information or your application specific logs, right? So the
Mm-hmm.
model might not be knowing what's going on with the application or how it was built and everything, right? It doesn't have much context on it. But when you provide the context to it, okay, what this application does, and if you just if you give the model a whole README file of what exactly happens in there, the model will understand the context. Oh, okay, what's going on with the application, And all you need to do is can provide your previous logs or tickets that has been generated and how you have resolved them. The model
Mm-hmm.
will then decide, okay, these are the logs I saw previously. So this is how it was fixed. And probably I should give a similar solution now or couple the previous solution with something else now and provide it back to the user.
Makes sense.
So
Okay.
that makes
Mm-hmm.
sense. So
Yeah.
this is how we have to determine and always think like the model is something like a junior engineer. The LLM is nothing but a junior engineer. He learned
Mm.
in his classroom that he might have learned everything, whatever book a book has, he learned everything. Whatever the Google has, he learned everything. But he doesn't know what exactly you are applying. Like, assume there was a new junior developer join. He doesn't know anything about the company on the very first day, right?
Mm.
So,
Mm-hmm.
how do you give the context of what your application does to him?
Mm.
So
Mm.
then only he will be able to better tackle that issue, right? And you can say, okay, this is, previously we have faced this issue, go through this troubleshooting guide or something and give me answer. Then yes, that particular person can go through troubleshooting guide and make changes to it, right? So that is how LLM works. LLM is like a guy who is like, who doesn't know anything about your company unless you give some information to him. So over
Mm.
a period of time, with like you might be seeing all this memory, semantic memory, episodic memory, and all this stuff that are coming in AI agentic frameworks. So what they basically do is like how a junior developer becomes a senior developer. So he knows the context on day one, some context. On day two, he knows something else. On day three, he knows something extra. And eventually he will remember all these things. And after few days, he will be able to solve the problems based on whatever you provide, right? So that is how the LLMs or AI agents also works. So their memory keeps on increasing day by day. If you include that memory component in your applications, if you don't include that memory component, every day he's like a junior developer. You have to provide him some auxiliary material to him in order to fix the problem. Make sense?
Yes. Yes. Got it. Thank you so much.
Sounds good. Thank you. Uh, yeah. Any other
And
question?
so just a follow-up. So
Mhm.
are you planning to teach the advanced concepts of this LLM in the future classes,
Yes.
or do you
So
have courses?
yeah, for
Mm-hmm.
this sessions, like for the next 18 hours or something, I
Mm-hmm.
will walk you through most of the other areas as well. Like, what happens exactly with LLMs and what happens with RAG. How do you evaluate RAG systems? What happens with fine tuning? What's the background of fine tuning? And then I will teach you through MCP and tool calling functions. And also, I'll teach you how to build agents using LangGraph as well. And I'll also show, we'll have a couple of practical classes if time permits, both on RAG as well as on LangGraph. I will teach you some techniques, how to include metadata, how to filter them, like what are the other various techniques instead of vector databases, what are the other RAG approaches that we can go through. We'll discuss all these things as time permits. Okay.
Mm-hmm.
And in detail, like if you need any more in detail sessions, right? Then we have like one, as Ramgar mentioned, KKAJNA has a 120-hour course, okay, where I am one of the mentor. So there are like few other mentors as well who are like very good. They work with like most of the Jains here. So they take few classes, I take few classes, but it's a 120-hour session, right? So everyone will come in as per time permits and they will take few areas and they will walk you through in detail how to build a production rack system, how to build a AI agent, production AI agent, and all those things. So they will teach both coding and non-coding. So few hours will be like mostly for non-coding, and you can also learn coding over there if you are just handy. See, you doesn't need to write or have in-depth coding knowledge. You just need to understand the language. If you are able to understand the Python language, then that's great. You are good to, you should be able to understand them very easily. To anyone, like if you just understand the Python language, Python is like pretty, int- simple and readable. So
Right.
if you are just able to understand it, you should be good. With all the vibe coding, if you don't understand, also ask Copilot what does this function does, what does this class does, and you should be able to understand.
Right.
Okay.
Yeah. Yes. Thank you so much.
Yep. We will also go through some machine learning as well. I mean, not focus much on it, but machine learning is the foundation to everything. If you understand, like even LLM is built on top of neural networks, right? So you should
Mhm.
understand what are weights. Like you might be listening to terms like, this particular model has 7 trillion parameters. Parameters means weights plus bias. So what are those weights? What happens in the background? So we'll also teach you through in detail in those classes. So Ramgar will explain better, to be honest. Yeah, they have a detailed session, like course plan and everything, so you can go through that and feel free to reach out to the team.
Sure. Sure. Thank you. Yes.
Yep. I
Appreciate it.
see Rafiq, Rafiq OP.
What is expert system?
Sorry,
Expert system. What is expert system? Expert system. What is expert system?
expert system. Can you give me more context on it?
No, I read somewhere experts about expert system. Anything related with AI? Expert system.
Yeah, I mean, usually people. Okay. It depends on the context, to be honest. So if you give me some more context, then probably I can explain you better. So people call expert system in multiple ways, right? Like for example, you provide some information and there is a simple plain AI model, assume, and it has a some knowledge base. If it provides a good recommendation, then you'll call it as an expert system. Like whatever you develop, right? An application that you develop, if it can make a decision like a specialist, like in the customer care, like for example, if I develop an application for the customer support and it can make a decision like a human or like an expert or specialist, then that is called expert system. For example, I built
Mm,
a model for
Radiology.
coding.
Radiology like that, no?
Yeah, radiology, coding, or anything.
Oh,
Like if I fine tune the system more on those specific areas, then yes,
oh,
that is an expert system for those specific areas.
oh. Is it different from fine tuning?
No, fine tuning a model will become an expert in that area.
Oh,
It will become an expert system.
okay, thank you.
Even with prompts, also sometimes it will become an expert system. We have, I mean, like there isn't any hard cut off rule that you should call this as an expert or something. But even in regular LLM, right, you will give a prompt system prompt where you can say that you are an expert specialist in medical field where you can diagnose diseases pretty quickly based on the symptoms, and if you give the symptom, it will act like an medical expert and provide an answer for you in medical terms. So basically, like that is how we call those as like expert systems having one category. Sometimes we'll have say you are a expert decision reviewer or expert in like what we say, writer or editor, something like that. So we make all these expert systems using the help of AI.
Okay.
Mhm. Yep. Did we miss anyone? Sahana?
I think, Aparup, can you go ahead? There are some people asking about the course plan and use cases, what we teach, GitHub projects. Just go over like 2-3 minutes and then we can clarify. Yeah, meanwhile, please raise your hand or maybe you can type your question in the chat box. Yeah, just to clarify, the plan 20 hours, whatever the boot camps will be continued. But if someone looking for a full-time course, that we are starting from the next week, that is the intention of the announcement. But I mean, there is no disturbance to the current plan. So whatever we promise, the 4 weeks, the complete August month, we will teach every weekend 1.5 hour to 2 hours on the agentic framework. But if you're looking for a intensive coaching for the 120 hours plus from our side, That will start from the next week. Maybe Apurva, we can go on.
Yeah, sure. Thank you, Sripal, for today's session. And as discussed, we have planned for a 16 weeks course, which we cover in the, right from the beginning, starting with the foundations of AI and machine learning, deep learning, and also with the LLM fine tuning agents and agentic AI frameworks. So usually we have like 14 weeks of sessions, and last 2 weeks, like week 15 and 16, we have GitHub project implementations. Totally, it's like a 16 weeks program. It's starting this month. So this course plan is already being posted in the chat by our team. You can take a look at it for the reference. So to start with, we conduct 5 sessions in a week, and also like we start with the foundations of some of the AI terms to familiarize with you, like what is generative AI, and what are the subsets of generative AI, like machine learning or deep learning or NLP. So in the first week, we'll go over all the prerequisites that are required for the complete course. Here you can see like AI, ML, DL, and NLP, and what are the terms, tokens, embeddings. You'll be learning about them. And what about prompt engineering? There are so many concepts in the prompt engineering, like chain of thought, and also like zero shot prompting, one shot prompting. So in the first week, we'll familiarize all the concepts to you, and then we go on to teach you with the Python libraries that are required for the generative AI. So we'll teach a few sessions on NumPy, Pandas, and also some of the libraries which are helpful for you to build the AI applications. So in the second week, we'll be going over all the Python libraries, and we'll be giving you recorded sessions on Python from the previous batches, and also will guide you like what is required and how you can start if you're coming from the non-IT background. So definitely will guide you on how to prepare or how to get hands-on with the Python libraries. So once you are good with the Python, in the week 3, we'll be starting about machine learning and deep learning. And we have, some of the concepts like supervised, unsupervised, and also like some concepts related to deep learning, like CNN, RNN. We'll go over all these sessions in the week 3 and 4. Even week 4 consists of natural language processing. So you'll be understanding like about different concepts under these 2 weeks, which are related to machine learning or deep learning or NLP. Then, based on this 4 weeks concepts, we'll implement a use case. So this is completely like 10 hours use case. You can see we'll implement in the live session so that you'll get get an idea where to start and where to implement the project, so that you'll be in the beginning stage you'll be familiarized with the concepts or the use cases that we are implementing. Once this 10 hours use case is completed, then we'll start with the generative AI concepts. So we'll start with the LLMs. We'll teach what are LLMs and what is transformer architecture, and also how you can fine tune an LLM. Everything will be completed under this week. Then comes the RAG. So we'll teach complete RAG architecture, and this is the main RAG and agentic AI frameworks are have been very popular in the market right now. So these are very important concepts, and we'll teach you how to implement the use case based on these concepts as well. So when you come to the agentic AI frameworks, the LangGraph, True AI, or LangChain, MCP protocols, these concepts will be covered under week 8 and 9. And so this is basically the core concepts of generative AI and core concepts of our teaching concepts. So definitely this will help you to prepare for the interviews, and also like it will add some weightage to your portfolios and resumes too. So here comes 2 use cases, 10 hours each. So basically, if you can, we'll implement this complete use case in the live sessions. So if you can grab this information, then definitely it will be really helpful for you to understand and go for career switch into AI, or if you are upgrading your career from different domain to AI, these two use cases will be really helpful for you. And then we'll teach on cloud infrastructure, like how we can deploy on the cloud. It can be on AWS Bedrock or Google Vertex AI and Azure OpenAI. These services will be taught in our sessions, and also simultaneously with these concepts, we cover some of the no-code tools which are helpful for the product management or project management, or if you're coming from the testing or automation background, definitely these tools or these sessions will be helpful for you to get some of the concepts related to Notion AI, ClickUp AI, or N8N, or some of the other tools like automation tools like Zapier, Make.com. We'll implement all this in the week 12 session. And also we plan for the cloud certification. So because everywhere it's cloud right now in the enterprises. So we'll guide you like how to get the cloud certification from this end. And also we'll teach you on the GPUs. So we have a GPU lab in Atlanta. So if you're nearby, or if you're local to Atlanta, definitely you can uh, visit our office. We can discuss more on the GPU lab that we have in the office. And week 15 and 16 will give you projects access. Let me quickly go over the project GitHub projects, where we give around 30 projects. So you'll be working on those 30 projects. That will be helpful for you to get the hands-on with different, different use cases. Let me share the GitHub quickly. So you can see the GitHub projects here. So we have a 3-level GitHub projects. One is level 1 beginner level projects, where you'll be working on 10 different project related to different domains. We'll guide you on how to implement these projects. So we have 10 different industry domain projects related to healthcare, finance, legal, and education. And each project consists of like a step-by-step implementation guide, and also you have problem statement, project objective, and system architecture, and also some of the the implementation guide which is required for you to start with. And we also have level 2 projects, where you'll be working mostly on once you complete beginner projects, we'll give you access to the level 2. You'll be working mostly on RAG pipeline, vector databases, and agentic workflows and automation. So this will be also like 10 different projects with 10 different domains that we have. And we have level 3, which are advanced projects. Here you can see we have multi-agent orchestration, and also LLM fine-tuning or LangGraph, cloud deployment, and you'll be working on full stack AI projects in the level 3. So these 3-level projects will be helpful for you to understand how to implement, or what are the frameworks you'll be implementing and where to start with. So definitely you can, we'll give you access to all this one. If you are interested, just try to enroll in the feedback. I mean, in the link that is being already provided in the chat. And during the sessions, so we have some of the projects where I can see, where I can show you. These are the like different domain projects, 10 hours projects that we implement here. So we almost have 14 projects, but we'll pick some of the project and explain. And each project will take around 10 hours to implement in the live sessions. For example, if we take customer support AI chatbot, which is related to customer service or e-commerce, and these are the categories we have, like AI or ML foundation, LLP concepts, RAG search, generative AI, system design, everything will be covered under this use case. And also these are the detailed concepts that will be covered under this use case while implementing in the sessions. And you'll be familiarized with the different, tools or frameworks, and what is the skills that you can upgrade while seeing this project live in the sessions. And we'll guide you on the certifications part too. So we have different certifications related to, like, OpenAI or Anthropic, AWS, Microsoft, NVIDIA. So these certifications will give you, like, guidance on how to get complete certification done from our end. So this will be helpful for you in the overall scenarios. So if you are interested, just let us know. Just you can reach us. The contact information and everything is posted in the chat. Try to reach us. So definitely will help you out.
Thank you, bro. Yeah, I think that's like an overview about the new batch. So please try to see if you want to join for the full track course. But for this free course for the next 4 weeks, yeah, please try to join on time, 11 a.m. to 1 p.m. So tomorrow also we will conduct on the same time. Please be on right time. That's one of the sincere requests. So with that, I think we can move on to the queries. If you guys have it any, please raise your hand. Yes, if any course related, please try to message or try to fill that form within the chat box. Razi, we done. Sahana, do you want to talk? Reddy Garu, Vishal, I think I'm trying to unmute you all. Yes, this 4 weeks you'll be giving a free course, like both Saturday, Sundays. So we plan for 1.5 hour class, 1 to 1.5 hour class, and the remaining 30 minutes for a Q&A. Yeah, if there are no questions, you are feel free to exit from the today's class. We almost spent for 2 hours. I know it's too late for India students. For USC, I know it's afternoon, but for India, it's too late. Thank you all for joining. Yeah, if there are questions, please stay back and try to unmute yourself. We can spend 5-10 minutes. If there are no questions, please feel free to exit from the class.
Uh,
Please join on time tomorrow.
Sir, it's regarding this the recent batch you will be starting. Like, what will be the timing? It will be on weekend or weekdays?
Both weekdays and weekends from Wednesday to Sunday. We will
Okay,
announce the timings soon. Okay, please give us some time.
sure, sure, sure.
Yeah, yeah. Yeah, I think the Sripal, I think you can drop off. Thank you. Yeah. Maybe we can handle it from here, from next 5-10 minutes if somebody having any questions.
Thank you all.